Welcome to week 6 of software engineering. Hope everybody's doing great. This week, we're going to start talking about what happens after the system is completed. So we've basically gone through all these steps, requirements, modeling, testing, design testing, all that's good. And we implement it to production. So what happens after that? Does all the needs for changes go away? And the answer is no. Okay. This week, we're going to cover maintenance types, including corrective, adaptive, perfective, and preventive approaches, refactoring techniques, and the challenge of technical debt, software reuse and re-engineering strategies, and continuous integration and continuous deployment, CI and CD, and DevOps, which we basically know about that from previous, is one of the development methods that we use in order to develop applications. Okay, so let's go ahead and move along. Okay, software change. Software change is inevitable. It's going to happen. There's no such thing as putting in a system and never having to change it. Okay? It just doesn't happen. Okay, new requirements emerge, the business environment changes, errors are repaired, they happen, bugs are prop up, new computers and equipment are added to the system, the performance and reliability of the system may be improved. A key problem of all organizations is implementing and managing change. That is a big part of the cost of putting in a new system. Here is a spiral model of the development and evolution. You see here, basically, this is basically saying that we're going to end up having multiple releases. Release 1 is just the first. As things happen, we'll basically go in operation. We'll end up having new specifications. We'll implement those specifications. Then we'll validate, and then we'll put it back in operations again. So we're basically in a spiral. We end up with release 1. Next time we change something, release 2, release 3, and this is continuous. We will keep going and having multiple releases every time we need to change something in the system. Evolution of servicing. If you looked at over the life of an application, software development, software evolution, which this is basically covering the changes, software servicing, where different things in the environment change, so we have to make those changes to the system. And then eventually we get to retirement, where the system is just basically too old and it's time for us to rewrite it. Evolution, the stage in software system cycle where it is in operational use. Things change, but hey, we're moving quite hunky-dory into using the system, getting our benefit out of it, and making changes as we need to. Servicing, at this stage, software remains useful, but only changes are made or are required to keep it operational. We're not adding any new things to the system. We're just making sure that what's there works. And then phase out, the software may be used, but no further changes made to it. It's an old system. It's better to replace it than to change it. So that is what we're going to be doing with this particular system at this point. Here, just kind of the software evolution process, change requests. We have an impact analysis. We go to release planning. We change the implementation. We might have to cycle through and go through release planning again. Okay, eventually we have a system release that says, okay, we made the changes and we're going to release the system to production again. Do we have release planning? We have release planning because of fault repair, platform adaptation, where environments change, and then system enhancements that we make to the application. Here, change implementation. We'll have change proposals. We'll do a requirements analysis of those proposals. that may end up being a cycle through, in that we are going to propose changes, requirements are not good or not made up the way we should. So we'll go back and we propose more changes. So we're in this cycle until we come out with the updated requirements. And from those updated requirements, we do our software development, as we've talked about over the previous weeks. Software maintenance and modern practices. Software maintenance overview definition: enhancing and fixing software post-deployment, post putting it into production. Ensures long-term functionality and relevance. There are 4 types of maintenance tasks that we could possibly go through. Corrective maintenance is where we're fixing bugs. Something doesn't work right. User says, this is the logic isn't right, so we have to change it. So we correct it. It's a reactive approach, which means that something has to happen before we do anything. We're waiting for something bad to happen in order to fix it. Adaptive maintenance adapts the software to new environments, covers operating system, hardware, third-party API changes. Anything as far as the environment changes are going to basically fall under adaptive maintenance of things we might have to do. Excuse me. Perfective and preventive maintenance. Perfective is improving performance and usability. Preventive is identifying and fixing latent faults early. Okay. We know something's wrong. Rather than waiting for something to fail, we're going to go ahead and fix it now, rather than waiting to be more of a reactive type response. Refactoring, restructuring code without changing behavior. We're changing the code, but we're not expecting something different from what it's doing now. It improves, maybe improving readability, maintainability, extensibility, common techniques, extract method, rename variables, remove duplication. All of these are making the system run better, but not changing the ultimate function of what the particular application is doing. A refactoring method is extract, breaking down large functions into smaller, so they're easier to maintain. Focus methods improves readability, reusability, testing. Rename variable methods to make it cleaner, so someone can, if we do need to go in and make changes, self-documentation, changing the names of variables, this sort of thing makes it easier to make that maintenance go and quicker for us to make sure that we can correct things because we can identify it quicker. Remove duplication. If we have a program that has a lot of duplication in it, we may want to take those and make subroutines out of them, or methods out of them, so that we call the method or call the subroutine rather than rewriting code. So this is getting rid of that duplication, again, making the system more efficient, so that in the event that we do have to maintain something, it shouldn't take as long to correct. The benefits of refactoring, reducing complexity, improves team productivity, and facilitates easier debugging and testing. Things are cleaner. Technical debt. Okay. Metaphor: taking shortcuts now increases future costs. Better yet, pay me now or pay me later. Okay, pay me now or pay me later. Caused by rush coding, lack of documentation, skip tests. So these are things that we did to make things go faster, but what we're doing is we're delaying the inevitable. By doing these type of things, something's going to fail in the future, and we're going to have to pay for it. That cost hasn't gone away. It's called technical debt. And we should have done something we didn't do because we wanted to do something quicker, and not better. And that, in essence, puts in place that potential for technical debt. Managing technical debt, regularly refactor legacy code, automate testing and code reviews, and document technical decisions. Software reuse, reusing existing software components to save time and costs. For example, libraries, various frameworks, APIs, application program interfaces, promotes reliability and consistency. Types of reuse. We can have reuse at the code level, functions and classes. We can have reuse at the component level, where we take modules, and within those modules, we're basically reusing functions and classes within the various modules and libraries. And system level, where we have entire subsystems that we'll use or reuse in order to make our application work, okay, rather than rewriting those sublevels to use them. Software reengineering, analyzing and modifying existing systems for improvement. Objective is to extend the lifespan while reducing costs. We want the system to last as long as possible. By doing some of these steps, or many of these steps we're talking about, we can extend the life of the application, and that's what we want to do. Reuse versus reengineering. Reuse prevents reinventing the wheel. Reengineering modernizes outdated systems. Okay, so one is reusing something that's already there. The other is say, hey, look, we're gonna do this from scratch. Okay, and we're going to improve it that way. Both improve productivity and reduce risk. CI/CD pipelines, continuous integration, regular code integration, and automated builds, continuous delivery, automated deployment. Basically, all this is saying is that this is, when we make changes, it's not going to be a one-off. We're not going to do things by accident. We're going to plan these releases. We're going to plan this looking at code in order to make corrections beforehand. We're going to plan to make sure we don't have any technical debt. And with that, when we do that integration, we're going to automatically, once we find something, we're going to automatically move it into production. Okay, we're going to automatically deploy it. We're not going to wait for things to happen. We're going to make it part of our normal job to make sure that we're doing these things on a regular basis. And with the automated part, making sure that we automate the process of deployment, just again, as a standard. This is what we're going to do. Benefits of CI/CD: faster release cycles, reduced integration issues, automated testing ensures higher quality. We talked about DevOps. DevOps is involving operations, develop and operations together whenever we make changes, collaboration between develop and operation teams, shared responsibility for system reliability, and encourages automation, monitoring, and continuous improvement, using the DevOps development method. This is basically CI/CD and DevOps in practice, using applications like Jenkins, GitHub Actions, GitLab CI. These are basically just products that we can use to kind of enhance our CI/CD and development practices. Okay. So this is just for a note that these are products, or these are systems that we can use to support this. Okay, that's basically it, looking at what happens after we put something in production and what we have to do to maintain it. Ideally, we want to keep a system as long as possible, 5 years, 10 years. Not 10 years. But the potential is there. The longer we can keep a system and maintain it, the less cost we're going to have to re-engineer or to rewrite it from scratch. Okay. So we want to look at these particular methods we talked about, and just be aware that after we deploy something, the fun just begins, and it's not an end. Okay, thank you. We'll see you in class or via the discussion forum. And so I'm sure you'll have some questions as we move along with your project. Let me know if there are any issues or questions. See you soon. Bye.